Hi, my name is Dr. Brian Anderson. I'm an Executive Associate Dean at the Bloch School of Management and an Associate Professor in our Entrepreneurship Department. Most of my teaching and research centers on inference, which is drawing conclusions from evidence and reasoning. Now, in today's world, most of this work involves data and modeling in some way. There has really been an explosion in reporting on and the availability of models and predictive models. And it can be challenging sometimes to evaluate the usefulness of these models to make decisions. And that's particularly true when models of the same problem or phenomenon come to very, very different conclusions. So I want to talk about three things that you can do to be a more informed consumer of data and of models. And these things apply not just to models you use or are thinking of using in your organization, but also to models that you might see reported in the media. The three things are differentiating between possible and probable, uncovering assumptions, and sampling. So let's talk about the first, differentiating between possible and probable. So the two concepts are very different from each other, and to use them, we need to uncover two key pieces of information. Right, the first is the range of possible predictions. And I think a bell curve is a helpful analogy here. Right, the second is the probability of each specific prediction occurring. So if we go back to this bell curve analogy, what makes up the curve is a number of individual predictions. Right, at the tail ends of the curve, these predictions are ones that are possible, but they are also likely to have a very low probability of actually happening. Now, in the middle of the curve are predictions that we think have a high probability of happening. Okay, so to maximize the usefulness of the model to our decision making, we need to identify that subset of predictions in the middle of the curve, right? These are the ones that we think are the most probable. And we do that because we have to make choices. We can't do it all. And understanding probable outcomes helps us to focus on a narrower set of choices that are most likely to be the most consequential. Now, we don't want to ignore predictions that are possible but not very probable, right? Those are the tail ends of the curve. But it is also critically important to put these low probability predictions in context, particularly when thinking about a cost-benefit trade-off of a particular course of action. Now, the second thing is uncovering assumptions. Every model has uncertainty. And the more complex problem the model is trying to predict, the greater the uncertainty. When we construct the model, there are going to be things that we have a good sense of and things that we do not have a good sense of. When we think about models that involve people in some way, right, these models are even more complicated because they are dynamic. People change. And these changes impact the usefulness of the model over time, which increases the number of things that we don't really know well. So each of these things that we don't really know well in a model represents an assumption. And for complex models, small changes in an assumption can make a large change in the model's predictions. So the more assumptions that are in a model, the greater the uncertainty around the model's usefulness. Now, it doesn't mean that the model is necessarily wrong or fundamentally flawed, but it does mean that we need to be careful in placing a lot of confidence in the model's predictions. So lastly is the importance of sampling. To make its prediction, the model must use data. Now, sometimes that data is simulated, sometimes it is real world, but almost always the data is a snapshot of the true population we are interested in learning about, right? The data is a sample. Now, choices in sampling can make a significant impact on a model's usefulness. So consider, for example, the data on hospitalizations stemming from the recent coronavirus. If the sample draws on people who were tested, but the people who were tested were those who were already showing symptoms and considered to be higher risk, well, the model is likely to predict a much higher rate of hospitalization because the data was already biased. It was skewed to a particular subset of the population. In this case, the people who were already more likely to be hospitalized. Now, the same logic applies to many business questions. So for example, if we were to try to predict whether a customer is going to buy a product, but we only ask our current customers, well, our model is likely to overestimate purchasing intention broadly in the population because we're only asking a small subset of people who have already purchased from us, and this is a group who may be more likely to buy from us again. Data models and inference are part of our daily world, and that's true in our organizations and it's true in our personal lives. They can be very useful and very helpful to inform decision making, and particularly in uncertain times. But it's also critically important to know that all models have limitations. Differentiating between possible and probable, uncovering assumptions, and really digging into the sample the model used will help you be a more informed consumer of data and of models.